let's okay, we are live. Let's get going. Hello everyone, welcome back to Data Vault. This is going to be a continuation of the last one where we started looking at how to create a terminal interface for our application, and then towards the end we actually included a way to run the application with a single command. So we created a continuous terminal session where you could open it up and it would just stay open for a while. You could log in and execute all your commands from within the terminal. And then we also had one where you just execute a single command at a time, put in your password, and it will log in, execute the command you give it, and then it will also log out at the end. And we talked about a couple of the uses for both of those. Today we're going to be kind of continuing on with that, and we're going to add a layer of security. So right now what we have is, let me find the main file here. So we had a test, we had a test suite, the terminal, which was just the continuous session, and then we also had a single command one where you could take in commands at a time. So what we're going to do now is we are going to take where it's finding this password from this argument here, and we may want to just input this through the terminal without the command, and we might want to mask it. So for example, I know on Linux, if you do something like if you do a command with sudo, what you have to do is you have to enter your password, but it's not going to display the password in the screen, because it wouldn't just say like if I said dv my password, that's visible to people. So if anyone's looking on, they can see that. And it also remains in your terminal history, like it'll remain in your terminal buffer. And what we kind of want to get is a way to say, all right, dv, and then it prompts you for your password, like down here with like enter password, and then you enter your keys, but they don't pop up, they pop up as asterisks, not as the actual password. So I'll kind of diagram this out. So you had your bash here, and you run dv, let's say add, or dv set Lego username, my username. So note here how there is no password, but Data Vault obviously wants to log in so it can access your data. Hence, it's going to prompt you here and say enter password, like so. Oops. And then you're going to want to type in your characters. So let's say my password was my pwd. So this is my password here. So I could just type in my pwd, and I would end up typing that, but we don't want to, again, we don't want to see that here. What we want to see is something like this. 3, 4, 5, 6. We want to see six asterisks. I think that's how you, well, that's the plural. But you want to see six of them, so your input is masked. So the way we're going to end up doing this is we're going to be playing around with return character, carriage returns, backspaces, and a bunch of other escape characters. So one of the ways that you could think about how to display this, so it's obviously not going to be a simple get line. So we obviously won't be able to just call get line, because get line actually requires the input to be shown on the terminal, and then it gets it. So the terminal takes in the input, and then it gets funneled into the buffer, waiting for get line to be called until a new line is, or until enter is pressed. And the same with get char. So both of these functions actually require a new line to be pressed, and in the meantime, the characters that are being entered will be displayed on the screen. So we can't do that. So those are not viable at all. I don't know why that's a highlighter, but you get the gist. So these are not viable viable functions at all. So what we have to do is we have to use the middleman function, which actually just reads a character press, a key press on the console, which is get ch, and this is going to be platform specific. So on Windows, if you include conio.h, you get this function get ch, and this will actually just return the character that is pressed. It doesn't funnel it into a buffer, it just takes it straight from the terminal. And I know there's an implementation in Linux for this, but we're going to focus on Windows for now. So this is in conio.h. So get character returns a character value, or an integer rather, but just a numerical keyboard code. And there are a couple of special ones that we want to be on the lookout for. So the first one is 13. So we'll say C is equal to get character. So C is equal to 13. This means a new line, and hence we want to end the input. There's also C is equal to 3, which I forget what that specifically is. Sorry, give me 2 seconds. So C is equal to 3 is end of text. So somehow if you input that, I suppose we could also say C is equal to 0. That's just end of text. And so we want to, again, terminate the input. So we want to funnel it in and actually process what has been entered so far. Now, the range of characters that we do want to take in are C must be between, the characters are 32 and 126. So it has to be within this range, so the printable characters. So again, we're going to be asking for input that is within these characters to actually process, so that your password cannot contain anything other than these characters. And then the last character that we want to look at is C is equal to 8, which is the backspace. Yes, there is in fact a backspace character. It's an escape character \B, and it physically represents a move back. So, for example, if you had a string that was HELLO \B I J K, what would be printed is, if you called printf on this, is it would print out HELL and then O, but then it backspace, so it moves the cursor back. So O, here, let me scroll down for you guys. So it'll print out the O, but then it'll move the cursor back and overwrite the O with an I, then JK. So you end up with HELLIJK, which is pretty cool. So these are the key presses that we want to be aware of. 3, 0, end characters. 13 is a new line, so this terminates our input. 0, 3, or 13 will terminate our input. Then we have the printable character range, and then C is equal to 8, which will represent the backspace. So when you press the backspace character, it is physically read in as 8. And then there's also 120. I think 127 is delete. So I think we are also going to, or do, because delete deletes the next character. So do we want to print that? No, we don't. We're not going to accept delete. Only backspace. Okay. So then there's also the problem of, all right, well, we're able to read input and we're able to kind of map a user's input and keep track of what they're entering. And if they delete something, we can represent that physically using the backspace character. There is another problem, which is, all right, well, how do we print it out to them? So what we could do is we could just say, we could just have the terminal be enter password. I don't know why hold on. My tablet is going all whack today. So we could have enter password, and that would be the first input. And then as soon as we read a get character, we call the command CLS, which clears everything. So this portion is no longer on the screen. And then we do enter password with the 1 asterisk. And then when the next character is pressed, we do CLS again. And again and again and again. However, this probably is not the cheapest way to do it. It's definitely not the most efficient because it just requires so many commands from the prompt, and we don't want to do this. So this is a big no-no. So what we can rather do, which is more efficient, is use carriage returns. So \R, and I forget what character code it is, but might be line feed. Carriage return is 0D, so that's 13. So this is equal to 13. We actually looked at that up here. 13 is new line, also \R. So when you hit the enter key, it really means \R\n. So enter equals \R\n. But it just gets funneled into get ch as 13. So we want to use this new character here, \R, which will essentially, so it will take your cursor and it will just bring it to the beginning of the line. It won't enter, it will just physically bring the cursor to the beginning of the line. So let's say we had a string printf hello, and let's do the same thing as before, but this time using \R_I_J_K. So we'll start by printing out hello, so HELLO, and then now your cursor is here when it reaches \R. So \R will bring the cursor and move it to the front of the line. So then we now just continue to write as normal. So we overwrite the H with an I, overwrite the E with a J, and overwrite the first L with a K. So what we're left with is IJKLO, which is pretty cool, actually. If you see a lot of terminal interfaces for installing stuff, like with Node or NPM, this is what they do. Just because it's so much simpler and it looks a lot, because if you do CLS a lot, it can actually just mess with the display, and it could create like a flashing effect, which you definitely don't want, because that's not good user interface. And it can also it's just a much cleaner solution and a much simpler one, just moving the cursor around with these escape characters, which is very fun, and you could definitely do a lot with it, and it's very fun to play around with. So let's go ahead and get started. We will go into a new file here called console.io.h, and we're going to start just with, or actually we'll go into main.c first. and we will just print. I'm just going to show you guys what those just that I'm not shitting you. I'm going to show you guys what those strings actually looked like. So first one was HELLO \BIJK, and then the other one was printf HELLO \RIJK. So if I go into here and I'm gonna run build or /build, and then cd, or I'll actually open up a new window for this one, cd run, or sorry, test/run /main. So this actually runs CLS, so we can't scroll up, but let me print these out and then I'm going to return 0 just to exit the program. Oh, I got to build again. Never mind. Okay, so we actually never even printed out a new line at the end, but this actually diagrams my point even better. So it printed out the first hello, HELLO here, right? HELLO, and then it did a \B, so bring in the cursor. So let me look at this here. So we have HELLO \B, moving back, IJK, and then the second print statement was HELLO, then \R, carriage return, then IJK. So the carriage return brought the cursor from here to the beginning of the line to print out the last 3 characters. So that's pretty much what we're going to be working with. So in console.io, we're going to have a couple of functions here, 2 actually. So we're going to say if not defined, console.io h define console.io h, and if console.io, and then we will have character get confirmation const char start prompt. And then, so this is, we're just going to be moving in. So the function that we have in terminal.c up here, we just want to move that into console.io just because we're going to group them better. And then the function to get our masked input. So character pointer returns a string get masked input. And this is just with the prompt as well. So I'm going to copy these 2 functions. Go here, and then we will include console.io.h, and then for get confirmation, I'm just going to take the function that we have here in terminal.c and put it in here. All right. And then we can actually just delete this function from terminal C and include the new one. So include the new file. Include .. // lib/util/ console.io.h. And before I forget, I want to add console.io to our build files. So need to run update run files.bat. So /update run files. There we go. And we see that we have build.bat, debug.bat, and run.bat as the modified files, which is exactly what we want. All right, so we're done there. So that's the first function. This should actually be prompt. So get confirmation is finished. That's just as it was before. And then we're now going to do get masked input. So what we're going to do is we're going to keep track of 2 different strings at a time. We're going to take input from the console, and we will keep that in a variable that we do not display. So we're going to call this the input string stream. So it'll be string stream. I actually need to include string stream. Include ... or is it ... It's ./ds/strstream.h, and then string stream input is equal to string stream allocate defaults. So we're just creating our input stream here. And then we also need to keep track of a string to display to the user. Now we could skip this and just, like in Linux, when you run sudo, all it does is it just displays the prompt, and you type in the characters, and you have to keep track of what characters you've typed, and it doesn't actually give you a visual prompt on what you have and haven't typed in terms of number of characters. I just want to be nice to our users. I want to give them the actual ability to do that. So we're going to say string stream masked is equal to string stream from string character pointer prompt. So this will be what is displayed to the user. So it starts with just the prompt, with the, whether that be enter password or whatever the prompt is. We want to start the masked off with that. So let's I'm going to do a little bit of a diagram of it's going to look like. So we're going to have the key pressed, and then we will have input and then masked. So the key, let's say, is H. So hence our input is now H, and our masked, since we want to mask it, is just going to be 1 asterisk. And then we do E, input is now HE, masked is now 2. Sorry, I'm assuming there's no prompt here, but I can just say PWD, and that's your prompt. PWD with a greater than sign, like so. And then we'll do L, so now our input is HEL, and then the masked is PWD with 3 asterisks now. And let's say they hit delete, so \B. Well, in our input, we just want to delete that character, so we can use the string stream retreat function, which just moves the cursor back 1, so HE. And then now masked, what we want to do is PWD. The thing is, we can't just do, we can't just retreat as well here, and I'll show you why. But if we did, you know, let's actually assume that you can just retreat, and we will see how that works. But you will see why it doesn't. And it all is based on us using the return carriage. So, you know, I'll actually just explain it now, and then we'll write the code. And I'll show you how it works with the incorrect version of the code. So, for example, let's say we were at this state where PWD and then 3 asterisks, and then they enter the backspace character. So they enter character 8, I think it is. So we retreat input by 1. That's fine. Input is internal. We're not showing it to the user at all. Let me actually start with PWD, the one with 2 asterisks is up here. So let's say we're at this point. So when the user enters L, so they get CH is equal to L, we now need to take the cursor that is over here and bring it back to the start. So PWD asterisk, asterisk, asterisk. So we've taken the cursor and moved it back to the beginning with \r, the carriage return. So now the cursor is here, and then we start entering our characters, pwd, but remember, we're just overwriting. So the p is replaced with p, w is replaced with w, and so on. This asterisk is replaced with itself again, but then when the cursor comes here, we're just entering a new character and things are normal. Now, when get ch is equal to the backspace character, we're going to do the same thing. So we take the cursor and bring it back to the beginning. So we enter pwd, or we print out pwd, and if we did retreat, we would only enter or print out two asterisks, because we have the prompt, then 1, 2, and then we retreated the cursor. 1, 2, 3, and then we retreated the cursor 1. So we only have 2 asterisks left. Now the cursor is here. However, this last asterisk was not overwritten, so it's still there because we haven't deleted anything. So what we need to do is, in the masked input, we need to provide a backspace, but then we want to overwrite this character. So we need to print out a space as well. So masked, we need to do a backspace. So we have, we get here, then we do backspace to bring back, and then we want to overwrite this character. So we do a space character. So with a space there. And then we want to bring it back again so we can continue writing. So what it's going to look like is, on backspace, we will retreat input. Retreat input by 1. But then on the masked, we need to add the string \b space \b. So a backspace, a space, and then another backspace. So the cursor ends up one character behind, which is where the user expects to be, but that last asterisk is no longer there. And again, I will show you guys all the cases on how this works and doesn't work. So we'll start by printing out masked.string, just as the first prompt. And then we're going to say character is equal to get character. This needs to be included from conio.h. So we need to include conio.h and then also stdio.h. Right, and then we're going to do our loop. So while the character does not terminate, or while a string does not terminate, this means characters does not equal 13 and character does not equal 3. So this means end when the character is a new end of line. So 13 or 3. And then we're going to detect backspace. So if character is equal to 8, we're going to say string stream retreat reference to input 1. So it seems like we're back, potentially. I'm just going to make sure, I'm going to confirm that we are. Okay, where were we? Okay, we're here. We are back. Okay. I think we're here. Yes, we are. Okay. So we were at the backspace. Sorry about that. Oh, my largest apologies. So we were at the backspace, right? What we want to do here is when the user enters the backspace character from getch, so just a raw backspace character, we want to retreat the cursor of the input string. So str stream retreat reference to input and 1. So we're just moving the cursor back. And then, for now, let's just try doing string stream retreat a reference to masked and just do that as one as well, and we will see how that works and how it looks. And then we now, otherwise we want to add it to add the entered character to the buffer if it's a printable character. So else if the character is greater than or equal to 32 and less than or equal to 126. So this was that range I was talking about before. So string stream concatenate referenced input %c and character. And then we'll do the same thing for the masked input, except this time we will, instead of entering the custom character, we want to enter just an asterisk, just so it prints out like that. And then we're going to print out the new string. Again, we're not doing clear screen, so we need to use a carriage return. So printf \r for the carriage return, then %s masked.string, because again we're only outputting the masked, and then we're going to get the next character. So ch is equal to get ch. All right, and then if get ch returns 13 or 3, then we will go and we're going to break from the loop and we want to return stuff. So we first have to clear our masked input. So string stream clear reference to masked, and then print out a new line, because again, get ch is just taking the raw input. It's not actually outputting it to the terminal. So we need to manually print out this new line to advance the cursor to the next line. And then we return input.string. Okay. So this is all good. Again, let's go through it. We have our two buffers here. And actually, I should say here, if it's a backspace and, I'll show you guys what could actually happen. So I'll save that. So we then get characters, and if it's not a new line, then we determine if it's a backspace. If it's a backspace, we just retreat the cursor. Otherwise, we add it to the buffer and print out the new masked output in the same line with the return carriage there. All right, so let's go into main.c. We will include console.io here as well. So include /source/lib/util/console.io.h, and I'm just going to say all right, so character, you think the sounds are a little lower? Okay, thank you for letting me know. Okay. Okay, I might just need to talk a little louder, but I can also up my, the gain just got completely reset. That's why. Yeah, the gain on my microphone just, all right, that should be a little better now. Desktop. All right, so we're gonna get our input here. So character pointer password is equal to get masked input, and we'll say the prompt is just password with the greater than sign. Let me know if the volume's better now. And then we'll just print it out for now to say we got %s password, and then free the password, and then return 0 after that. So we're just going to test this out with the quote-unquote incorrect code. All right, so I'll open up PowerShell. Well, what happened? Implicit declaration. What the hell happened? It doesn't. Oh, you know what? When I turned off my surge protector, I was in the middle of this file here. So I'm just going to recreate the file. So we'll just go delete, and then I will recreate it just because I don't know what it's finding in there. All right, so console.io.c with the new line at the end. And then let's try this now. Nope, it's still not liking it. Oh, god damn it. Null characters, I have no clue what that means. Wait, hold on. This is the previous run. Implicit declaration. What the heck? What is going on here? Do I need to recreate console.io.h as well? I'll just try that. Console.io.h. Okay. And okay, there we go. I don't know what it was. I don't, because when I flipped off the surge protector, it was it didn't save it properly. I don't think so, but we're good now. All right, so I'm in my run directory, and I'm gonna go /main. All right, so we have. I don't know what, you know what this sounds. This honestly sounds about right for me. Let's just, let's get rid of the input that we had before this whole stuff here, because I did not put a single new line in those strings. All right, /main. There we go. So that's our prompt right there, password. And what we're going to do is we are going to, I'm just going to type in J. So we got an asterisk. Good. Notice how when I hit control, nothing happens. Hit delete, nothing, or delete, I guess actually. Delete does stuff for some reason. End also does stuff. I don't like that, but I'm going to start hitting delete. I'm going to start hitting backspace. So doing backspace. And notice how the cursor is moving backwards, but these characters are staying out. And again, the reason why is because we are doing the carriage return, but we're not actually overwriting those characters. So they're still there in the terminal. It's just we're only writing up to here. So that's going to be the one issue that we get to solve by replacing the the retreat with a full backspace. So we need to, instead of doing retreat on the masked character, we need to say string stream concatenate reference to masked, and then \b. Now, if we just did \b, the result would be the exact same. So we need to add a space and then another \b. So in the end, the cursor ends up one character back, because there are two backspace characters and one forward character. But that asterisk will be overwritten. So let's go ahead and build, and then we will run /main again. So password dfgh, and now I'm going to hit backspace, and you see that the cursor moves back, but we also don't see that last asterisk anymore, which is precisely what we want. You see that you shouldn't be able to do that. That was the thing I wanted to figure out. But since this is technically, since we don't even have a guard on when to retreat, so for example, this input could have no characters in it, but if we continue to retreat, this will be fine. This function will be fine because it's just not going to retreat any further, but we continue to concatenate the backspace characters. Hence, we need a check here saying if the character is 8 and input dot size is greater, or and input dot size. We'll say that. So CLS dot slash main. Oh, I need to build again. So I do dot slash main, and then I do a couple of characters. And if I continue to hit backspace, it doesn't go any further. So it's always going to print out the full prompt, and then some. So let's actually try and get a string here. So I do IOP QWERTY backspace backspace FG. All right, so we have the IOP, the QWER, then the TY, and then we deleted those two and replaced them with an F and a G. So the input is tracking null. It's tracking null, which is precisely what we want. And you can honestly stop watching the video right now. There's nothing. If you wanted to watch this as a standalone console input video, go for it. We're going to actually now look at how to integrate this with our application. So in terminal.c, I'm going to head up here. We already replaced or deleted the get confirmation function. So we are calling the version that's in console.io.c. However, we now also would like to, I just closed the wrong, there we go. So now we would also like to add this masked input. So let's start with adding it to the commands where we want to log in and create an account. So that will be here. So when we do log in and create account, we don't want to get the input from the tokens. We want to get it from this masked input. Hence, we're going to take the two functions here saying else if string equals login and then create account. We want to move these up into the 0 argument functions, so or 0 argument commands. So you can just paste them after print in the section with the commands with no arguments here. So we have create account and we have login, and we are now just left with the dilemma of how do we get this this new password. So all we're going to do is we're going to say, and we're also not going to print out creating an account because that's also just breaching security. So we're going to say character pointer password is equal to get masked input. Password is the prompt will just be the same as before, password with a greater than sign, and then we, instead of passing in tokens at 1, we're going to pass in PWD, and then create account, the string length with PWD as well. So we're just replacing the token argument with the password, and then afterwards we want a free password as well. And then same thing for login. So character pointer PWD is equal to get masked input password, like so, and then we're going to replace tokens at 1 with PWD and then string length of PWD. Okay, and then finally we want to say free the password. So we get it as a masked input, and then we will log in and create an account. We will do the exact same command, the exact same function. It's just this time we're taking the input not from the command tokens, but just from the console itself. So let's go ahead and in here we're going to do CLS. I got to build. This is why they made IDEs, but I'm being stubborn. And I just close out of that. All right, so I'm going to run /main, and let's say our command is log. So we just want to see what there is. So I'll do that, and forgot this isn't main.c. Oh, right. So it's looking for, yeah. So single command before, to launch single command, we needed two tokens at least, because there was the /main and then there was the password. Now it's just going to be the /main because the password, we haven't programmed it yet, but it will be taken in through the masked input. So this should be else if argc is greater than 1. I'm actually supposed to be testing the continuous session in terminal. So this was working as expected. So build, so /main log. Now, this actually works because it wants us to enter the password. So I think test pwd was the password, logged in, and then something wrong happened. Let me just do /main. I'll log in here, test pwd, success, good. So we logged in there. I'll log out. I'll create an account, and it wants to enter a password, test pwd, log, and there's nothing else. And we, I guess, log in again with test pwd and then log, and there's nothing, which is good. So the confirmation still works as well. But masked input is working on the continuous session. Now the little more complicated version is going to be getting in the single command. So we have hello terminal, all good, clear the screen, initialize the app, and we want to construct the login command. So right now we are expecting that the password be passed in the first token. This time, or instead of that now, we're going to give the user the option of passing the password, but we also will allow them to say, hey, I'm not secure enough to do that. I want to keep my password not visible on the screen. So instead I just want to, I want to enter it with a masked input. So us as a practical application designer will say, yeah, sure, that's fine. But you just need to indicate that to us if you do pass in your password. And we're going to do that using a switch. So what we're going to do before constructing the login command, because we're going to log in no matter what, we just need to determine what we're going to use for the password. So before that, we need to find it. So find the password either in the command or through the masked input. So we'll start with the character pointer password is equal to null. And then this password will be what we pass into the login command. And I suppose we actually don't even need to do the string stream anymore. We can just print out, or instead of processing the command, we just need to call the controller function. So result is equal to dv login reference to app, the password, and the string length of password. So we don't want to go through the overhead of processing the command. So we don't want to stringify it and then parse the string that we just stringified when we already had it parsed. It's easier just to call the controller method right here. So we have if result, and then we're also going to want to have a switch that will say, hey, we did find this character or this password in the command. Sorry, give me 2 seconds. So we're in the single command. So if you want to enter the password through the command line, we don't want to free that string. So we can't just blindly say free password here. This won't work. I mean, it will, but the thing is, what happens if the password does come in from argv? We don't necessarily want to do that. We only want to free it if we do get it from the masked input. So what we have to say is we're going to create a switch up here. Boolean free password is equal to false, and then we will set it to true if necessary, and then after logging in we will say if free pwd, then we will free the password. Okay. Next, what we're going to do is we're going to find the password in the command. So we will say the switch has to be a -p. So we're going to assume that the command, so I'll actually just put a comment up top in a single command. I'll do that in the header file. So this is open a continuous terminal session. And then here is just so you're going to run a single command. And then I'm going to diagram what will happen here actually. So the commands, so command formats. So it should be dv.exe or whatever the run file is. And then if you want to enter a password, it should be -p, then your user password, and then the command. So the point is -p must be the first. That must be the first argument. Otherwise, you can just do dv.exe command, and it will then prompt you for the password. So command format with password, and then command format without password triggers a prompt. So you can either, again, just enter it through the command, or you can just ask the program to prompt you for it, which I think is a good design. So we're going to look for that switch. So we'll say if string compare argv at 1 -p. So if this has some value, then did not enter the password. So we need to find it. We need to get it. So we're going to say pwd is equal to get masked input. Password is the prompt. And then we're going to say free password is equal to true. And then we're going to continue. Otherwise, the password was entered with the switch. So else password in command. So we are going to say pwd is equal to argv at 2. And then we keep going from there. However, this does raise a problem. We assumed that the password did come in with the command here. So we took this here. We took the command as argv at 2. So we assumed that the password was the first argument. Now it's a bit more gray in the sense that we don't know if the command started on the first token, because if the first token was not -p, then it means it was the command. Otherwise, argv at 3 will be the first token of the command. So we need to create a counter. So we have our variable I here, which does this very well, actually. And we're just going to say, hey, we're going to declare I at the top of this function. So we're going to say int I is equal to 1. And if we did not enter the password, then the command starts at 1. So we don't need to change I at all. If we entered it in the command, we need to say I is equal to 3. Because argv at 2 contains the password, so I is going to be equal to 3 then. Like that. Okay, and then apart from that, it's going to function the exact same, except this time command here, it'll be string from string argv at I plus plus, or just it's I, sorry, and then do we do I plus plus? Pardon me. Yes, I plus plus. So yeah, we want to take the first token of the command and then advance in the array. So right now, let's go ahead and try and actually run this. Hold on, I just need to make sure I've been showing you guys my desktop. I'm pretty sure I have. Yeah, I have. Okay, we're all good. Just making sure. Well, it shows it on YouTube that I am, so I'm gonna trust that. All right, so let's go ahead and build and then run. /build, and then /main. So we'll do main, and we will run the command. Let's say set Lego username. All right, so I'll hit enter. So it's going to prompt us for the password to start. So I'm going to enter my password, test pwd, enter, logging in, executing command set Lego username, setting data for Lego under username, success, logging out, goodbye. All good. Now let's try that again, except this time we're just going to get the Lego username to make sure that it does work. All right, so we get the password again. So test pwd, accessing data for Lego and username, retrieved Lego username. Good. Let's try entering it with the switch now. So we'll do /main -p test pwd, and then we'll just say log. All right, so we logged in with the password and then executing command log. So our cursor or the counter is set up properly, which is good and fun. Let's try doing the other one, get Lego username with the password. And it still works. Good and good. Now, what if you wanted to create an account from the single command? We haven't really addressed that situation yet. But you're not going to be able to log in if you don't have an account. So we're going to have to create another format for the command. So we need to add a separate format here saying if create account with password. So it's going to be the same format, dv.exe-p. So we're always going to look for the password in the first token. And then so we will get the password as normal, either from the token or from the masked input. We're just going to determine if the command wants to create an account before logging in. So new password, and then create account is the command, and then we will give ourselves a first command there. And then if create account without password triggers a prompt. So it'll be the exact same, just without the switch. So dv.exe create account command. So the password detection is the exact same. We're just going to, once again, we're just going to test that first token before constructing our login command. So we need to say determine if we want to create an account. So if not string compare argv at I create account, then I'm just going to do printf creating account. Then we're going to execute the command, and we'll just use the controller method directly. So result is equal to dv create account, pass in a reference to app, the password, and then the string length of password. So we're just using the same password as before. And again, we're not going to free the this is the first time I'm saying this, but we're not going to free the password just yet because we still need it for the login command. But we do need to have an error check here saying if result, then printf could not create account, and then break. Otherwise, we need to do one other thing, and that's advance the cursor, because the commands will now start after that. So ++I, like that. And then I suppose before logging in, the single command could just be to create an account. So we might just want to do a check here saying determine if there is in fact a command. So if I is greater than or equal to argc, then we're just going to break because there's no command to execute. And we'll test around with this. So let's go back here, /build CLS, and then /main create account. So create ACT. So it's prompting me for a password. It doesn't see one. So I'm going to enter my password, test pwd. So creating an account, and because there's no other command, it's just going to say adios. Let's try passing in a command. So create account, or sorry, /main create account log test pwd, and it's going to execute the command as we want it to. Now let's try doing create account with the password. So create account, sorry, /main create account -p test password log again. That's not right. Let's see. Did I may have screwed something up. Oh, I put in again. So create account was the first token. However, the first token, even if you are creating an account, if you're passing in the password, that needs to be the first token. So I made the mistake here. So it should be /main -p test password, then create account, like so. Didn't find. Oh, because okay, that's stupid. Yeah, this is right. I was thinking of something else. But what it does is it finds the password as test password, creates the account, then I'll log. Let's try making sure that it did create with the proper password, and it did. All right. So yeah, that is pretty much. I think that's going to wrap up our terminal interface stuff for now. I guess we could always add an extra layer where we say in process command we can always let's see. In process command, we might not want to write out the data that we're setting. So what we could end up doing is have else if this is our set command with 2 arguments. So I'll put that over here. Else if string equals set and argn is equal to 2, then we want to take in or set data as masked input. So we're going to get our input. So character pointer data is equal to, let's see, what's it going to be? Masked input, get masked input, enter data, like so. And then we will do return code is equal to dv set entry data as per normal. So referenced app, arg tokens at 0, arg tokens at 1. And then the data this time will just be data. And then we free the data afterwards. So we have the return code, and the only difference is we're just taking in the data from the masked input. But this only happens on a set command Oops, sorry. This only happens on a set command when argument n is equal to 2. And by the way, this will happen on the single command as well, because we will call process command on everything that comes after the credentials. So let's try this. So we'll do a /build, clear our screen, // main. So let's just open up a terminal session. So I'll say login, and I want to enter my password like so. Success. I'm going to say set Lego, or I'll log first just to see what's up. Nothing. So set Lego username. Lego username. I'm going to log get Lego username. Oops. Like so. So it got that. Now let's try setting a password for Lego. But again, we don't want to print it out. So we'll say set Lego password, and then it's going to ask us to enter the data. So we'll say Lego pwd. And then I'm going to then say get Lego password, and it retrieves it for us, which is perfect. Now there could be a couple of problems here. Again, I guess this isn't terminal input and output, but what if we don't want what if we want this to be masked? That's not the subject of this video. But let's try doing it from the command line. So I'll do a logout, then a quit. So / main set. Again, if anyone wants to donate their social security number, just put it down below. So I'm going to say / main set SSN value. So theoretically, what should happen is we should be prompted for a login password, and then we should also be prompted for the value, our social security number. So password, I'm going to say test pwd, logged in. Executing command, set SSN value. There are 2 arguments, hence it's going to prompt us for a third one, and I'll say, what's my social? You guys don't know, and you guys can't see it. Is that too many characters? No, that's right. Enter. So it set it with the masked input, which is very nice, and then since it was a single command, it just logged out. So let's do / main get SSN value, test password. That's my social. All right, that's all I have for you guys today. Play around with this. Play around with the escape characters. They're very fun to play around with. But anyways, I hope you guys enjoyed. I hope you learned something. I will see you guys in a little bit. Have a good one.